Hello everyone, this is our project Housing Price Prediction. Nowadays, people are more interested about the property pricing and how may we price a reasonable data for a housing property given the features of it. This is what we're going to study within this project. We get the data from Kaggle and a program called Zillow Price. It contains 58 features of the real estate properties. This can help us feed the real world pricing rather reasonably. The first step to deal with the data is to deal with the missing data. We first count how many missing data, what the proportion of the missing data of every column is. And after doing that, we either replace the missing data with a reasonable number, such as the mean value of the column or the median value of the column, or we just drop the missing data. After dealing with the missing data, we did the feature engineering part. For feature engineering part, we combine several features into one so as to select the more efficient combinations of features. And sometimes we drop the data which is useless. After the feature engineering part, we did the feature selection. We first study about the covariance matrix of each column, each feature with regard to the final target value. As you can see, we've selected out the 9 most effective features out. It is shown as the right part of this picture. And what we did, the other part is we did the visualization of separately of the correlation between the value with regard to different features. After dealing with the data, we started to feed the data with the algorithms and methods. We first think of the regression algorithm with elastic net regularization. Well, as we can see that the columns, the features of the data is rather big, we decided to decrease the number of the columns to select out the most effective one. However, we decided not to do that manually. We decided to apply the elastic net regularization. It will help us to sort out the most effective columns, which mostly reduces the effects of the loss of this transformation. And after the model specification, we did feed this model using Spark. As we can see that we split the data into 80%, 20% as the separately as the training data and test data. And the parameters set as this after some tuning. And finally, we get the root mean squared error on test data as this. It's a big, but give a consideration to the original value. The value is rather big, so with comparison, this is rather considerable given the comparison. And we pick some of the test data out to see the effects. The effects is as shown on the right part of this picture. We can see that it's a rather good effect. And the prediction and labels, they are corresponding to each other in some degree, a well correspondence. However, we are not satisfied with this model. We try to pick up some more models. We think of the random forest regression. The random forest regression is a ensemble learning method for classification, regression, and other tasks that operate by constructing a multitude of decision trees at the training time and outputting the class that is the mode of the classes or main prediction of the individual trees. The random decision tree is correct for decision tree's habit of overfitting. For this model, we manually pick up the most effective 20 3 features, which is most relative to the final target value. And also similarly, we feed it with a Spark, and this is the parameters. After parameter tunings, we set a parameter like this. And as you can see that the root mean squared error for this test data is smaller, much smaller than the previous one. And also as part of the test data, we can see that they correspond to some degree of web correspondence. And this yielded a smaller root mean squared error. Well, as for a brief conclusion, we think that the random forest regression, comparing to the regression with elastic net regularization, it is more sensitive to the different training data. And the parameter tuning is more difficult than the elastic net regularization regression. However, with the regression with elastic net regularization, it is relatively more stable than the random forest regression. And however, when comparing these two models, the previous one, the random forest model, yielded a much better root mean squared error. So we decided to adopt the random forest regression model for prediction. And we designed a UI for customers to query the data. This is our website. As you can see that there were input areas and the query button. For this kind of things, you can input. The customers are welcome to input their ideal feature data into this feature fitting blanks. However, we also set the default number as is shown here in the blank areas of every column. And we can see that there were 10 columns and the other features, indicating other 13 features that the customer are interested in. But that is not the most interesting with regard to the normal housing prediction features. Let's say that we're interested in housing with 2 bathrooms, 1 bedroom, and 2 pool number, and it is built in 1990, and the unit number is 3, and let's fit this. And for the other features, we can also input some values in there. And let's query. It will yield a prediction of the housing price. Also, it is applicable to input just a proportion of this number. Say that I'm only interested in about the bedroom number, the 4 bedrooms, and the other features are set as default numbers, and we can also query the data. It will get this out. So finally, this is our project. Using the big data method, the Spark, to model the housing price prediction and help the users to query the predicted pricing of the house given the features of the house. Thank you very much.